All right, so today we are going to be starting on something new, right? Because we took our test last week on probabilities, right? We had theoretical and experimental. We were talking about all the different ways we can use probability to understand the world and use math to help make things easier and be able to make predictions. Okay, and companies do that all the time. But today we are starting something new, and we're going to be talking about triangle inequalities. Okay, so I'm going to share my screen with you, and just remember, you can always press escape to get it out of full screen if you want to put your slides next to mine, okay, or if you want to pull up your other files. So let me put this in present mode. Do that for now. Okay, so triangle inequalities and what that means and the different properties of triangles. So exactly, today is May the 4th. May the 4th be with you. If you've ever seen Star Wars, right, they say May the Force be with you. And today is May the 4th, so most people know it as kind of a Star Wars themed day. It's just a fun thing to do, and if you've never seen Star Wars, highly recommend it, especially the originals. Some of the best movies. So as we start today, just a fun thing to think about. Maybe you can watch a Star Wars movie with your family tonight or something. So we're going to be talking about triangles, and the objective here says I can determine if 3 side lengths will make a triangle. So if we have the 3 lengths of a triangle, right, the length of this side, and this side, can we find out if those 3 lengths make up a triangle? Okay, that's what we're going to do today. So does it make a triangle? We will be exploring if any 3 side lengths can make a triangle, like we just said. To start off, you need to do the following. So number 1, you need to open the Google Draw activity that says 5-4A. Okay, 5-4A, building triangles. And it should look like this with this little spinner in the top right. Okay, so let's all do that. Let's do step 1 together. So if you don't have those files open, go ahead and open that first one, or if you do, go to 5-4A and click on that Google Draw and have it open up to where you can see this spinner and this chart here. Okay, so we'll take about 30 seconds to get that open. Go ahead and do that now. I'm going to pause. I'll come right back up on the share here. Just making sure I see what you guys see on the classroom page. Okay, awesome. All right. So probably about 10 more seconds. Make sure you have that file open. Again, if you want to make sure that you're following along and that you're doing well and that things hopefully are clicking, make sure that you are indeed following along and having this file open. All right, so we all have our file open here with the spinner. So step 2 is to click on the spinner and click on the link for Geogebra. Okay, so I'm going to do that same thing. So let's say I am right here, 5-4A, building triangles. I got my 2 guys here. So I click on the spinner, and there's a little link down here. You're going to click on that link. Okay, so that's loading. While that's doing that, I'm going to click on the thing that says Geogebra, and it pops the link below that one. And I'll click on that one as well. And so now I should have these two links as well. So I've got a spinner, and then I have this GeoGebra file here with kind of a triangle here. Okay, so here's the instructions. You're going to spin the spinner 3 times to find 3 possible lengths and record your 3 measurements in the table below. Okay, and then you'll go to GeoGebra and try to build a triangle with the 3 measurements you found. And then record your result in the table. So here you'll say, let's do one together, and then I'll let you guys do the rest. Okay, so let's say I do my spin. I get a 6. Okay, I'm going to do this 3 times. So 6, 1, and 8. So 6, 1, and 8. So then I go over here, and I would say 6, 1, 8. Okay, and what I'm going to recommend for you guys is just get all your numbers first. Okay, and then you can just do all the GeoGebra ones next. Okay, so we've got 6, 1, and 8. So then I could go here, and I'm going to have to click refresh. Okay, and so I can change these lengths. I can say, okay, 6, 1, and 8, and see if I can make it into a triangle. So this one says, yeah, the lines are intersecting, but that's going to be sticking out past, right? So maybe I could try to make that go really far, but it doesn't look like it'll work, right? I can't make it into a triangle. So what I then say is I hop back to my page and I say, can it make a triangle? Nope. And then I go on, okay, and I do the next one. All right, so I want you guys to do that. Spin your spinner 3 times to get 3 lengths for each. And then once you've done that, use GeoGebra to check each of those and say, can you make it a triangle? Yes or no? Yes or no? Yes or no? Yes or no? Okay, so go ahead. We'll take a little bit of time doing that. And yeah, so go ahead and get started on that. And I'll be doing the same, and then we'll check and see what our results we got together. Okay, so today we're going to do some self-experiment. All right, guys, we'll say about just a few more minutes. So hopefully by now you should have all three numbers for each row, and then make sure that you are checking on Geogebra and see if you can make a triangle with each of those. Wow, that's pretty wild, Jonathan. Got some lucky number sevens. All right, so if you are not all the way done, that is okay, because we're going to be doing another bit of kind of self-exploration here on this activity. The spinner, Preston, good question, is, I'll share my screen. It's on the Google Slides. Okay, so if you have, well, it's up, sorry, it's not on the Google Slides. It's on the Google Draw file, the one that says 5-4A. And when you click on there, it should have this picture. If you click on the spinner, it has a little link underneath. Okay, and then you click on Geogebra, it has a little link underneath that one as well. Good question. All right, so yeah, hopefully you've got your numbers filled in here. If you're not all the way done with checking Geogebra to seeing if your values connect and make a triangle, then continue doing that. But we're going to go ahead and just kind of introduce the next step here, okay? So it says, for us to do that, right, record our results and say, is this a triangle, yes or no? Can we make a triangle in this one, yes or no? Now, based on what we observed, okay, the next thing we're gonna do is 5-4B, 5/4B, so reflecting on triangle building. So we built some triangles, right? We got random numbers, built triangles, or tried to anyway. And now we're gonna kind of see what the results were, like, you know, why some worked and why some didn't work. And so there's kind of a pattern that you'll notice with these triangles, right? We're kind of figuring out how come some three lengths could make a triangle and some three lengths couldn't make a triangle. So based on what you saw and what you are finishing up, I want you guys to go to this next file, and we're gonna answer these following questions. So there's only 4 questions. You're gonna say, you know, number 1, is it always possible to form a triangle if 2 of the sides are exactly the same length? Explaining your answer. Is it always possible to form a triangle if all 3 of the sides are the same length? So you answer these questions as best as you can. Okay, you type your answer, and yeah, and use the results that you got to figure out what you think the answer is. Okay, so we're kind of filling that in, and then we'll discuss it and talk about what we got. All right, so take about 5 minutes. It's just over a minute for each question to think about it, type it up, and get your answer. Okay. All right, so 5 minutes starting now. All right, a couple more minutes. Hopefully you're getting close. Okay, about 1 more minute. Right. Wow. Okay. All right. So hopefully you guys were able to fill in your 4 discussion questions there on what you think about the patterns that you noticed and the different results that we got. So I'm going to, again, share my screen. Okay, so you filled in these 4 here, and let's talk about it. So the first question asks, is it always possible to form a triangle if 2 sides are exactly the same length? Explain your answer. So when I did it, I got some different results, and I noticed that no, it doesn't always mean that if we have 2 sides of equal length that we can make a triangle. Because one of mine was 4, 4, 2. And even though there's 2 sides that are the same length, 4 and 4, I couldn't make a triangle out of this. Or sorry, I reversed that. 4, 4, 2, I could make a triangle, right? Because I could have a 4 and 4, and then have it just be really skinny at the bottom and be a 2 length. So this one does make a triangle, right? But when I did 4, 4, 10, that was the one that I couldn't make a triangle out of it. So even though I had 2 lengths that were the same, the 10 side was so long that the 4s collapsed, and I couldn't make a triangle out of it no matter which way I rotated it. So having 2 sides that are exactly the same doesn't necessarily mean that I can form a triangle. Sometimes yes, sometimes no. Is it always possible to form a triangle if all 3 of the sides are the same length? Yes, okay, that triangle is a special triangle, and we call it an equilateral. Right? You may have heard that before, you may not, but an equilateral triangle, it sounds like the word equal, right? So equilateral triangle is because all 3 sides are equal length. So it could be 3, 3, 3, it could be 7, 7, 7, like I think Jonathan had, right? You could have 3 lengths that are all the same length. If they are all the same length, you can always make a triangle, and it's an equilateral triangle. Okay, number 3, observe the results from the chart above. Okay, the chart that we did. When is it impossible to form a triangle? And the answer basically is when one of the side lengths is really long while the other are too short. The other 2 are shorter. So when we had the 4, 4, 10, for example, or when I had the 4, 4, 10, the one side was 10, right? It was pretty long. The other sides were 4 and 4. And even though I tried to make a triangle out of it, again, 4 and 4 only made 8. So it's not even long enough to make a straight line to get to the end. So there's no way I could tilt it and make it a triangle, okay? And number 4, from your previous observations, when is it possible to form a triangle? And that's what I want you guys to put here real quick. I've been talking too much. So I want you guys to type in the chat, take about 20 seconds, type in the chat what you put for number 4, okay? So you can just copy and paste your answer from number 4 and put it in the chat. Okay, so go ahead and do that now. I want to see what you guys discovered, what you guys think you figured out. All right. If they are the same length, okay. Good, let me get some more responses. We got a decent little crew here today. So just put what you guys put for question 4 in the chat right now and send it. Oops. All right, go ahead and put it in the chat, guys. I've got still waiting on something from several of you guys, Nikolai, Candace. Don't be shy. There's no penalty. Just put what you guys thought for question 4 in the chat. Okay, good. Thank you, Candace. Good. She said when two sides can meet. Good. All right. So maybe you're not quite there. Maybe you're still finishing out your questions, and that's okay. Good. Thank you. I see we got maybe when all lengths are close, all the numbers are close to each other. Good. Or when two sides meet. Good, guys. Thank you. Excellent. So all you guys are really close here. All kind of coming towards the same thing, which is kind of what I was shooting for. So we know that it's always possible to form a triangle when all three side lengths are the same, because we said, that's called an equilateral triangle, and if it's 3, 3, 3 or it's 8, 8, 8, we know that that'll always work out. And then, so when is it possible to form a triangle? Like when the three side lengths aren't too far apart. And what I would kind of say is, actually, I don't think I have my draw file up. Okay. But if you can kind of visualize, I don't know if you can see me on the screen. Hopefully you can. If we had a side of a triangle, right? Like let's say this was the one, my 4, 4, 10 one. So like, let's say this is my 10 length, okay? And if I have a little 4 piece and a little 4-inch piece, 4 and 4 would just make 8, right? If this is 10 from, let's call this point A to point B, then if this is 10 inches from point A to point B, and I have a 4 piece and a 4 piece, if I put them straight together, like end to end, then it would be 4 and 4, and that would make 8. So, but it wouldn't reach all the way to point B, right? And the whole thing with the triangle is we have to have all the, we have to have 3 vertices, 3 spots where the lines come together, right? So it's not like I can say 10 here and then 4 here and 4 here, because it wouldn't be long enough, basically, right? Now, if it was 10 and it was 7 and 8, something like that, those would be long enough to where I could make that a triangle. But if it's just 10 and a 4 piece and a 4 piece, that only makes 8. and so that won't work to get to the full 10. Okay, so so this is our triangle inequality rule. Okay, and I want to make sure. Okay. Okay. All right. So this is crucial, guys. So this is what we're talking about today. It all boils down to this triangle inequality rule. The sum of the two shortest sides of a triangle must be bigger than the third side. Okay, and I'll say that one more time. So the sum, right, adding the two together, of the two shortest sides of a triangle must be bigger than the third side. So in our example here, when I was using my pen, this is a side length, like if this was our 10, that's the biggest side, right? And the 4 and the 4, that one didn't work because the sum of the two shortest sides, the 4 and the 4 in that case, they have to be bigger than the third side, which was 10. And 4 plus 4 is 8. And that's not bigger than 10, so that's why it didn't work. Okay, so that's the inequality rule, the triangle inequality. So here's this image up here. Sum of two smallest sides must be greater than the third side. Okay, so look at this image here. 4 and 5 is not greater than 10, so a triangle cannot be made. Okay, I want you guys to really look at this image on the left. So that's what we're saying. If 10's my pen here, right? Even if I had one that was a 4 and one that was a 5 this time, 4 and 5 only make 9. And so even if I put these straight down or up, right, those blue lines represent places I can put them, I can't make a triangle. They won't connect. So that doesn't make a triangle. Okay, and then on this one, we've got 10, but we have 8 and 7. Okay, 8 plus 7 is greater than 10. That makes 15, right? 15 is greater than 10, so a triangle can be made from this one. Okay. Let me see. Sorry, I had a chat. I am on slide number 8. Slide 8. Okay. So, all right. So that's our inequality rule. That's what you guys need to make sure you kind of commit here to practice in memory. The sum of the two shortest sides must be bigger than the third side. All right. So we're going to practice. So one last time, I'm going to have you guys work independently and try practicing the inequality rule. So now that you guys know the rule, you won't have to just experiment, which hopefully was helpful, with the GeoGebra lines, right, and spinners. This time, I'm just giving you 3 side lengths, and based on the inequality rule, I want you to tell me if you can form a triangle, yes or no, for these triangles. Okay. So, yeah, and so you'll just say on your file here, okay, on your Google Draw file, this is the last draw file for today, 5-4C. You'll use the rule that says that the sum of the smaller two sides, whichever two smallest sides are, must be greater than the length of the largest side. If it is greater than the longest side, then yes, you have a triangle. Okay, so shouldn't take too long, probably about another 5 minutes to work on this. If you have a question, you can always privately chat me or publicly chat, either way, and go ahead and get your answers, right? And then one last time we'll discuss, and we'll be wrapping up. All right, so I'll get off your screen here, take about 5 minutes, and get your answer. Yeah, and if you need to type in the, oh boy. If you're having trouble typing in, then you make sure you double click into the box, and then you can type into it. Yes. Sorry, I also just realized what that comment was. You can also, on the slide 8, if you're in present mode and you're using the arrows, that's when things will start appearing. So if it looks like it's blank, in present mode is when it'll show the text. Okay, about 20 seconds. Sorry, got distracted. Do. All right. Yes, we will. There's 3 Google Draw files in total, and we just finished the last one. We're going to discuss it, and then at the end, we will turn them in Pablo when we're finished. All right, so let's go ahead and see what we figured out, and hopefully we're all on the same page. So one last time, I'm going to Oh, good question, Briggs. So for these, you can use the GeoGebra tool, but we are, at this point, we're hopefully using the inequality rule that we figured out, which was that the two smallest lengths have to add up to be bigger than the biggest one to figure out these, okay? So you could use the GeoGebra one for a visual, which helps, but we can also use the rule. Good question. All right, so here we go. Okay, so the sum of the two small sides has to be greater than the third side. So on this first one, 8, 8, and 8, first of all, we said that's kind of a special one, right? If all three sides are the same, it can be a triangle. It's called the equilateral triangle. So that one we already should know is going to be yes, but we can check. 8 and 8 would be the shortest sides, even though the third one's the same. 8 plus 8 is 16. Is 16 greater than 8? Yes. So it is a triangle. Okay, what about this next one? The two lowest numbers on this one are 3 and 10, right? 3 and 10 makes 13. 13 is not greater than 15, is it? So that one's going to be no, right? What about this next one here? What did you guys get for number 3? Real quick in the chat, I want you guys to put what you got for the sum of the two lowest numbers and your yes or no answer for question 3. Go ahead, just real quick in the chat. We'll have one after class, Abigail, or near the end of class if you start then. And Preston, we will, but not till we're finished. All right, but real quick in the chat, tell me guys yes or no for number 3. What should I select? Oh man, you guys are more shy today than you usually are. But just real quick in the chat, just a yes or no for number 3. 12, 12, and 9. Can that be made into a triangle, yes or no? Slide 10, Preston. Got a no, I got a yes, good. Let's get a couple more answers. We got about 13 of you guys, 12. So let me get a few more. Abigail says no, Briggs says yes. What do you guys think? Pablo says yes, okay. Got a couple for yes, one for no. All right. All right. Don't be afraid to answer in the chat, guys. It makes class go a lot smoother. But we got, thank you to those that responded, Abigail, Pablo, and Briggs. Thank you, guys. So let's check it out. The two lowest ones would be 9 and 12, right? If we have 12, 12, and 9. 9 plus 12 is 21, right? That's what I have here. 9 plus 12 is 21. So then 21, is that greater than 12? Yes, it is. So 21 is greater than 12. So yes, it is a triangle. All right, this one. 3 and 4 are the lowest out of 3, 4, and 5, right? So 3 plus 4 is 7. Is 7 greater than 5? Yes. So it can be made into a triangle. Okay, we keep going. 4 plus 7, right? That would be the lowest 2. 4 plus 7 is 11, right? And so then 11, is that greater than 12? It's not. So that's going to be no. We can't make a triangle on that one. Okay, 6 and 8 make 14. Is 14 greater than the biggest one? It is. So that means it can be a triangle. 2, 6, and 2. That means 2 and 2 are the smallest. 2 plus 2 is 4. And then 4, is that greater than 6? It is not. So that's going to be no, it can't be made into a triangle. And then the last one, we've got 3, 5, and 8. 3 plus 5 is 8. Is 8 greater than 8? Nope, it's not, right? It's equal to 8, but it's not greater than. So it's going to be no, we can't make that into a triangle. It would just be two straight lines next to each other. Okay, great job, guys. All right, so I'm going to I've got my starry background now. So what I want you guys to do is on those Google Draw files, I think that I can go ahead, I'll let you know if I cannot retrieve them, but I think since I made it as a classwork file on Google Classroom that I'll be able to see what you guys wrote. So as long as you filled them out, I should be able to read them without you having to share all of those. Okay? So